Before jumping on to the notebook, I want to explain very briefly how these feature selection methods that I'm going to describe work. We're going to cover two different approaches. The first one that I called brute force approach. What it does is it scans features as they appear in the data frame. So they scan them in a random order as they appear in the training dataset. And if a second feature is correlated with this feature we are evaluating, it removes it automatically from the data frame. So in practice, what happens is that the method picks the first feature and then it compares the correlation with features 2, 3, and 4. And if any of these is correlated with 1, it removes it. Then it moves on to feature 2 and it compares its correlation with features 3 and 4. And if any of these is correlated, it removes it. And then it goes on to evaluate feature 3 and so on until it reaches the last feature of the dataset. The advantage of this method is that it's very fast. The disadvantage is that we may remove a feature that perhaps has a bigger predictive power than the one that appeared first in the data frame. Let's imagine that feature 1 is correlated with feature 2 and 3. This brute force approach method will remove features 2 and 3, but maybe feature 2 is better to predict the target than feature 1, and this method will not be able to capture this. The second method overcomes this limitation by doing the following. First, it identifies groups of correlated features. A dataset may contain different groups of correlated features. In this diagram that I show here, for example, we have these 7 features that are correlated among themselves. We have these other 5 features correlated among themselves, and then it has these 20 features correlated among themselves, and these 12. Then, from each group, it selects the best feature based on a certain criteria that we define as users, and it discards the rest of the features in this group. So from these 4 groups of correlated features, this method picks the best of the 4, so it will keep 4 of the features, 1 from each group, and we discard the rest of the features. How can we select the best predictive feature? It's up to us. One way is to build a small machine learning model utilizing, for example, these 7 features, determine the importance of these features to predict the target, retain the feature with the highest importance, and eliminate the rest. An alternative criteria would be, for example, to examine the number of missing values of these features and keep the feature with the less number of missing values. These 2 methods are the ones that I'm going to describe in the following Jupyter notebook. You have 2 options. You can come with me in the next video as we go over the notebook together, or alternatively, just read the Jupyter notebook on your own. It's very well commented, so you will have no problem navigating it. See you in a bit.